Hello students, how are you? Welcome to today's session of Daily Chemistry Dose. So what is stored in today's dose? The topic of atomic structure, and that too with a little scary topic, which is of the probability graph. Generally students find themselves little uncomfortable this particular topic of wave mechanical model, where the probability graphs are there in the last part of your this chapter. So since last many years this particular topic is the questions are coming from this particular topic. So there is a very beautiful question. I'm placing it in front of you. Just go through this question, try to solve it by pausing the video, and thereafter I will discuss it. So here comes the question. So I hope you have paused the video and have done this question, and now I'm going to discuss it out. So as regard to this particular question, so the radial wave function for some orbital is being given, and this scary mathematical equation which is in front of you generally frighten students that how to solve this question. So this is I can assure you, after this video you would you would start loving uh, solving these sort of questions, because this is very easy. So what is basically in this question? To discuss this question, I have to give you a little brief idea, a very brief idea, hardly in 2 3 minutes, that what exactly is going regarding this radial wave function. So actually in this topic of what you call it as, that in the wave mechanical model of atom, we actually wanted to locate the position of this electron from this origin. Origin is of nucleus and this electron is at some distance r. So this is the distance r, and I am saying this as to be the xyz coordinates, and it is at some point here. So for getting the exact location of this electron, I shall be requiring this distance, and also I would be requiring two angles, let's say theta and phi. So on the polar coordinates you would be requiring three things: r, theta and phi. And if you are onto the Cartesian coordinates, so you would be requiring x, y, z. So we generally use polar coordinates. Now what exactly is there, that the electron is associated with a wave function, and this wave function has the dependency on r, theta, phi. So this wave function in itself is consisting of two things. One is this, we call it as radial wave function. Radial wave function, the wave function in itself is combination of two things: radial wave function, and second part which we refer to as to be the angular wave function. So in your level, in till 11th or 12th class, we happen to teach more of you radial wave function rather than angular one. So here you have this theta and phi. So this is what, so this radial wave function has to depend upon, it depends on n and l, which is principal quantum number and azimuthal quantum number, and this happens to depend upon, this is the external information I am passing it to you, depends on l and m. This actually is not required in this particular question, but I have to make a sort of base for solving this particular question. So what exactly it is? So the wave function of an electron has dependency on two parts. One is the angles and other is the distance from the nucleus, that is the radial wave function. So most of the time we are being given the radial wave function, just like here you could see he categorically has written radial. So this radial wave function, now let me tell you what exactly it is. So this radial wave function can be written like this, radial, or they may simply write it like this, r. So this radial wave function, any of these two terms are prevalent. So this radial wave function is consisting of three things. One would be the constant, another would be a term called polynomial term, and last part is the exponential part, exponential term. And psi in itself has no physical meaning. This psi has no physical meaning. It's a mathematical entity, but this psi square tells the probability of finding the electron. So probability density or probability of finding the electron at a given space. So psi square has a physical meaning, but psi as such has no physical meaning. So it is a mathematical entity. Now what exactly we wanted to do? So you have to locate in this equation that this radial wave function in this radial wave function, there are three things which you have to focus it out. So this is what you call it as, or let me write it here. This part is what you call it as constant. So this is the constant part. And this part which I am referring here with the white marker, or rather I would say with the blue marker, this is the polynomial part. And this last part which I am marking it with pink, so this is the exponential part. So in all of these, you have to locate that they, in this particular question, they are saying that this delta, which is mentioned here, is actually it is actually made up of, this delta is what? 2zr upon a naught. So what does it mean? So z and a naught, as per the version, z and a naught are constants. So this radius is the varying thing. So as this radius varies, this wave function varies. So that radius term is either in this polynomial or is in the exponential part. So there are two parts in which the term r is coming. So what exactly we wanting to know in this equation is that if I change this distance from this side, so if I go this side or this side, if I keep on changing the distance from the nucleus, how this wave function, and that too radial wave function, is going to change. So you should know that when you change this radial wave function, a point where psi square becomes 0, or for that matter psi becomes 0, we happen to say that is the place where you could say it is be consisting of a radial node. Now, what is basically node? Node is a space around the nucleus where probability of finding the electron is 0. So, radial node, or you may also say it as to be spherical node. For that matter, so first let me explain it once again. What is node? Node is the space around the nucleus where probability of finding the electron is 0. And this node in itself is of two types, radial nodes and another is angular node. Angular nodes tend to give you shape, sort of shape to the, so it tend to create a space because of which you happen to see dumbbell shape. P orbitals are dumbbell shaped, d orbitals are double diffuse, or things like that. In particular region in the space you are having some lobe, and in other part of the region at some angle you don't be getting any electron density, so that is the node. So this in itself is a very interesting topic from which you can get a question. So there is a question based on this number of radial nodes. If I happen to write number of radial nodes, there is a formula, number of radial nodes, which is equal to n minus l minus 1. And if I happen to say number of angular nodes, this is equal to l, and total nodes you end up getting is n minus 1. So this is, these formulas are, so I will make some other video for especially for this particular topic also. Now let me conclude what I am, where I was. So I was on the verge of saying this thing, that is when psi square becomes 0 or psi becomes 0, that is the region, or that is the distance from the nucleus where the radial node would be. So he is interested to know that in this wave function, what shall I will make it equal to 0 such that you would get the location of the radial node. At what distance you would see that psi or radial wave function tend to become 0. So we wanting to know, in this question he is asking us that minimum and maximum position of radial nodes, that the distance from the nucleus, minimum distance from the nucleus where the psi has become 0, and for that matter psi square has become 0, and the maximum distance at which the psi has become 0 or psi square has become 0. So what we may do here is that I have to see into this equation such a way, in this equation I have to see it in such a way that I could make something equal to 0 such that whole of this equation becomes 0. Now it is quite simple. So if I take the exponential part, if I make exponential part equal to 0, it would not make it 0 whole equation, because anything power to 0 would make it 1. So now if I pick this equation, this part of this equation, if I pick it like this, as soon as I will do it, you would get to know what I referring to. So if I make psi minus 1, this is this the delta minus 1, and it is given as delta square 8 delta plus 12. This is what is being given. Let me check once again. Yes, it is exactly the same. So in this term, if I make delta minus 1 equal to 0, so this whole equation will become 0, because this is the multiplication and that too is multiplied with the constant and exponential term. So now what is delta according to this equation? Just check this out. It is 2zr, I think so, 2zr upon a naught. So it is 2zr upon a naught. So if I make delta equal to 1, so this means it is 2zr upon a naught equal to 1. For that matter, r is equal to a naught upon 2z. So at a distance of a naught upon 2z, because a naught and z both are constant, so at this particular distance you would see a radial node, because at that point of time at this location the psi square, or for that matter psi, has become 0, because the psi has become 0. Now another thing you can make it here is, you may also do it this way. If you make delta square 8 delta, sorry, it just has misclicked, oh sorry. So 8 delta plus 12, if I make this equal to also 0, the whole equation would become 0. So this is a quadratic equation for which there could be two roots available. Delta minus 6, this is equal to 0. So now I can create two more things out of it. So I can make delta minus 2 equal to 0. So delta is equal to 2, one is this, and another I can make delta minus 6 equal to 0. So that is also delta equal to 6. So what is delta? Delta was 2zr upon a naught equal to 2. So for this has become r is equal to, what r do I get here? A naught upon z. So another one is, this is 2zr upon a naught, which is equal to 6. So this becomes 3. So this happened to turn up to r becomes 3 a naught by z. So what do I mean by it? So I shall be getting, sorry, it is a naught by z. So I shall be getting three equations. So when I make delta minus 6 equal to 0, I would get this radial node at some distance of a 3 a naught by z, and a naught by z also I am going to get one node, and one when I made delta minus 1 equal to 0, at that point of time it was a naught by 2z. So these are the three locations or three distance from the nucleus where you would get the radial node. Another style of question they may ask on this thing is that, now we are through the question, let me tell you what is. So the minimum distance, this is the minimum distance at which I am getting the radial node, and this is the maximum distance at which I am getting the radial node. So this is what is being asked in this question. So first let us solve this question. What option do I get here? So I am looking for a option a naught by 2z and 3 a naught by z. So what is there? It is C option. Is it okay? So the answer is done with it. Now another style of this question can be asked in this way, that they may ask you, just hold on, they may ask you that this radial wave function could probably would belong to, this is another style of question which can be asked. So, say they may ask you like this, that this equation they may give you like this, a b c d, this equation, this radial wave function may belong to, say they may give you 1s, 2p, or they can say 4s, or say for example they can also place it as 2p, 3p, something like that. They can ask you that, this way, that this radial wave function may belong to. Now what you have done is, in this equation you have already solved that there are three radial nodes at a distance of this. So these are the three distance. First is at this point, second is at this point, and third is at this point. So this is for sure, while solving this equation, that there are the 3 points at which you can get the radial nodes. So now using this equation, this formula which I have already shared it with you, the number of radial nodes is this, n minus l minus 1. So I may do it here also. So in a one question, I am teaching you another one question. So n minus 1, n minus l minus 1 is the number of radial nodes. So the radial nodes would be, for the first one is 1 minus 0 minus 1 equal to 0. For this, 2 minus 1 equal to uh, this equals to 0 already. So this is 4 minus, so I'm assuming this much, you know, SPDF. This is 0, 1, 2, 3. This is the value of L. So 4 minus 0 minus 1 equal to 3, and here it is 3 minus 1 minus 1. This happens to equals to come out to be 1. So the answer to this question can be 4s. So this is another style of question. So I hope you have enjoyed today's session, and if in case you find it difficult, I shall be making one more video on such problems. So do let me know on the chat box if in case you want more questions based on this particular region. So hope so you have enjoyed today's session, and again we shall be meeting once again next time with the next topic in a daily chemistry dose. Have a nice day, take care, and stay safe. Bye bye, Tata. See you once again.